Okay, in this problem, in this video, I'm doing page 66, number 9. And again, we have a table of information on 5 different people, their annual salary, and then their annual income tax. And we have to answer some questions. So part A tells us that, it doesn't tell us to plot a graph, but it says if you were going to plot a graph, then what would be the average slope of the curve between the points for Eduardo and Camila's salaries and taxes using the ARC method. So now first we want to, even though we are not graphing it, it would be helpful to consider what we expect to be the independent and dependent variable between annual salary and annual income tax. So the question I have to ask myself is it that annual salary determines annual income tax? Or, so in other words, is it that how much you make determines how much you pay in income tax? Or is it that income tax determines your salary, so that, how much you pay in taxes actually determines how much you make? Now, I hope, the more intuitive answer for you, and maybe it's not because you haven't had to pay annual income tax yet, but I can tell you for sure that the more intuitive argument here is the first one, that annual salary determines how much tax, how much income tax you're going to pay per year. So annual salary in this case is going to be our independent variable, because it's determining the annual income tax, which is our dependent variable. So even though we are not going to be fully graphing this, we can consider what would our axes look like. Well, on the x-axis, we would have the independent variable of salary. What am I saying? It's not an index, that's independent. Independent. So that's the independent, and this would be your salary. And then on your y-axis, you would have the dependent variable, which is the annual income tax. So this is dependent. So then when we have a point on this graph, consider that we will have a point that first tells us the salary and then tells us the tax. And so that's how we're going to think about using the information in our table to determine the average slope between 2 points. So again, let's look. It says, we're looking at Eduardo and Camila's salaries. So Eduardo has an annual salary of $22,000 and income tax of $33,304. Camila has an income of $94,000 and pays an income tax, annual income tax of $23,927. And so now we have to consider, how we would calculate the average slope of the curve between their 2 points. And this is no different than what we've been doing. We'll choose one to be x1, y1, and another set of points to be x2, y2. And now we will just pop these numbers into our formula for slope, which is delta y, delta being the Greek symbol, the triangle being the Greek symbol for change in. More specifically here, we have the change in y, y2 minus y1, over the change in x, x2 minus x1 equals. And now we're going to plug in the numbers. So we have 23,927 minus 30,304. And then we have 94,000 minus 22,000 equals, let me just do that very quickly. Equals 0.29. I hope that's also what you got. Okay, so that is the average slope. So now, we can ask what this slope means. Well, consider that the slope is, rise over run, first of all. So let me just add that over here, rise over run. And let's also consider the fact that this 0.29 is actually sort of over a 1. Okay, and so this is our y over our x. This is tax over salary. What this is telling me, what this slope is telling me, is that for each dollar that I make in addition in my salary, I am paying 30% or 30 cents of that dollar in taxes. So let's just consider, if we go back up to this little graph at the top. Let me clear some room here. If we go back to this graph up at the top, let's talk about a slope that has it is 0.29. Okay. What a slope of 0.29, I just added up, means is that for every rise of 0.29, I move over 1 in order to get back on the line. So that means that one additional dollar in my salary is so another way you could look at it is this way. One additional dollar in my salary means that I have to pay 30 cents in taxes. Okay, so that is how we would interpret that. That slope. Now let's take a look at part B, and it's the same deal except now we're talking about John and Susan. Okay, now we're talking about John and Susan, and we are again going to use our formula for slope to calculate the average slope on the curve connecting John and Susan's coordinates. So John makes a salary of $3,000 per year and pays $454 in income tax. Susan makes $22,000 a year and pays $3,304 in her income tax. And again, I'm just going to pick one of these points to be x1 and y1, one set to be x1, y1, one set to be x2, y2. And now I'll just plug into my formula for slope. Change in y over change in x. Again, if you want to remember how to do this, just keep writing it over and over again. So y2 is 3304, y1 is 454, x2 is 22,000, and x1 is 3,000. And if I do that calculation, I get 0.15. This should be a minus sign. Okay. Okay. So so my slope here is 0.15. Now what does that mean? Well, that's telling us that, so let's say that the line connecting John and Susan, I believe, yes, John and Susan, looks like this. Okay. What we need to consider is that this 0.15 is actually over the number 1, and this is y over x, so tax over salary. So what this is telling us is that from the salary of John of $3,000, then an increase of $1 in salary is associated with an increase in the tax that you have to pay of 15 cents. Now it's important to keep in mind this is something I did not mention last time actually. This is the average sort of the average association in the bracket of a salary from 3,000 to 22,000. Okay, so this is 3,000 here. This is 22,000 here. And so in this bracket, the average sort of association is that if the salary increases $1, you have to pay 15 more cents in your income tax. If it increases $1, you pay 15 more cents in your income tax. That's what that slope means. And now let's just consider lastly the what happens to the slope as the salary increases in Part C. Okay, so the way we would consider, so Part C tells us to consider, what happens as the salary increases. And we can really just consider the two slopes that we've already calculated in Parts A and B. Moving from John to Susan, we're moving from a salary of $3,000 to $22,000. Moving from Eduardo to Camila, we're moving from a salary of $63,000 to $94,000. And the slopes there, in the first, from John to Susan, is only 15 cents on the dollar. So for each additional dollar earned in salary, you pay 15 cents of it in income tax between the salary brackets of $3,000 and $22,000. And so I've tried to show that in the graph to the right there, that you have John over there making $3,000, Susan making $22,000, and then I'm going to just I'm just said that this is what might be the slope of 0.15. But then as you increase in your salary, so from Eduardo you have $63,000 to $94,000 in salary that Camila is making, then you have a higher slope of 0.31, meaning that for each additional dollar added to your salary, you're paying 31 cents of that in income tax. So over to the right, I would say we're moving from Eduardo, who's making $63,000, so this is Eduardo, over to Camila, who's making $94,000. And the slope here, I've pitched it a little bit higher to indicate that we have a higher slope of 0.31. And so what we're generally seeing is that as you make more money, according to this problem, you're paying more in income tax. The question asks something about a person's incentive to earn a higher salary. I think that's a nonsense kind of a question. We really don't know anything about anyone's incentive at this point. All we know is how much they are paying in their income tax. So please ignore that portion of the question.